as discussed in the last video, we need a more sophisticated number, or two, that will measure the average amount of deviation from the mean for a data set. That's what the standard deviation and variance are going to do for us. Now, variance I keep kind of throwing in there. So what we're going to learn is that these two numbers go together, the variance and the standard deviation. In a basic statistics class like this, we tend to work with standard deviation more, but in an upper level class, say like a Stats 2 class or beyond, you would tend to work with the variance more. It has just to do with the mathematics involved. So I will keep talking about them a lot. I'm going to show you how to find both of them, but just suffice to say that they are strongly related, and we'll learn about that a bit as we do this, as well as on the next page. All right, so let's look at the sample of scores again from the statistics course. This is their dot plot right here. Remember that we have the mean. We saw the mean as that fulcrum, that balance point, which was right here at 74. All right. So the first thing we want to do is find the deviation. Now the deviation is when you take each of your values, I'm just going to put this in parentheses, and you subtract x bar, the mean, which is what 74 is. 74 is your mean, right? X bar is the symbol for mean. We learned that in section 3.1. Technically it's for a sample mean, but most of the time we're doing this for a sample anyway, so it's fine. Okay, so let's think. The x's are right here, right? So these are my x values. So 60, and I want to subtract the mean, which is 74. I want to take 100, and I subtract the mean, which is 74. 61, subtract 74, and so on and so on and so forth. And I'm going to get particular values. And they're going to have signs. For example, 60 take away 74 is negative 14. 100 take away 74 is positive 26. 61 take away 74 is negative 13. And so on and so forth. We don't have to show every little thing. Oh, and for the record, and I'll mention this again in either later in this video or next time in the next video, but we will never do this by hand again. This is a one-time only deal so that we can kind of understand what's happening, right? So what we're doing is we're finding the distance of these points from that mean. So this one is 14 below. This one is 26 above. This one is 13 below, and so on. That's what we are doing. And we can also use Desmos to help ourselves. I have heard tell, one of the reasons that I do this is that I've heard that some of the professors in other areas do make you do it by hand. So I want you to be able to practice that so you know what they're doing. So you can find all these values with Desmos if you don't trust your, mental calculator. If you're like, oh no, what is 61 minus 74? Then you can do it this way and find all these values. Again, we will never do this again. This is a one-time only deal to figure these out. And then from this point, I will have us do StatCrunch to do this. And StatCrunch does it beautifully. But there's some value in learning how to do this by hand. Okay, so I found all those values. So I'm going to go put them in our table. If I can get to our table. There's our table. Okay, so this one was negative 13, this is negative 9, this is positive 11, this is positive 16, negative 12, negative 10, positive 2, positive 3. Yes, you leave the signs in there. All right, now, here's the thing. Deviation is distance from the mean, distance from the center. So these numbers are measuring dispersion. Right? They're measuring spread for us. But the problem is that our instinct is to go, oh, okay, great. Well, then I can just add these up and divide by how many there are, and I'll know the average deviation, the average dispersion. Right. So let's add those numbers up, shall we? Let me go back to Desmos real quickly. All right, negative 14 plus 26 minus 13 minus 9 plus 11 plus 16 minus 12 minus 10 plus 2 plus 3. Hey, looky there. It's 0. To which I would say, well, of course it is, right? It's always going to be 0 because the mean was the balance point. You're looking for deviation from the mean, right? So we're looking for deviation from the mean. that would mean that this will always be 0 because the mean was the balance point. Which actually I asked about down here. So we want to find the average deviation, right? That's what we're looking for. What's the problem with adding the deviations right there? This question. So we just learned that. So I guess that's the first question. I don't know. I'll call it I, right? So it's really asking two questions. So adding deviations will not work. So adding deviations always creates a sum of 0. Because the mean is the balance point. These are deviations from the mean, and the mean is the balance point, so of course it's going to make 0. They cancel each other out. That's why it balances, right? That's why it's the fulcrum up here. The mean is the fulcrum because the low values and the high values balance each other out. That balancing is right here, right? That's why it will always be 0. So I'll star this so we can kind of see this. So this is right here. So always 0 because the mean is the balance point. Well, grr, because that's what we wanted, right? It's the deviations. This is so close to what we're looking for. This is great, right? Wonderful. And I can see, by the way, negative deviations. See, all the ones on the left had negative deviations because they're below the mean. All the ones on the right have positive deviations because they're above the mean. But that means that they'll always make 0 when I add them up. Grr. Okay, so, and these are the sums down here. I should have made that clearer. So I'm adding, and I will add down here too. There's going to be a value soon. Okay, negative deviation means the value is below the mean. Positive deviation means the value is above the mean. And therein creates the problem, right? That's why we can't just add them. All right, so what can we do to mathematically fix this? That's the second question. To fix the problem that we're having with the 0, the fact that it always adds up to 0. In mathematics, there's two ways to kind of fix this that are standard. One is to take the absolute value, which for various reasons having to do with calculus is not a great fit for us. That there is a value that does that, but we're not. It's called the absolute deviation, and we're not doing it. So we're going to do the standard one. And the standard deviation uses the square of the numbers. Oops, sorry, I have a camera or a light up there. So we're going to square those deviations. When you square a value, it makes it positive. Right? That's what we learn in algebra class. Okay, so let's do that. So let's go back to the top, right up here, and let's square all these deviations. So we are going to take the deviations, and we're going to square them. In other words, we're going to take the x values minus the x bars, and we're going to square them. And you put it in parentheses to make that happen. Okay, so negative 14. Negative 14 goes in parentheses, and you square it. Positive 26, you don't really need parentheses because it's already positive, but if you want to put it in parentheses, knock yourself out. Negative 13 squared, negative 9 squared, and so on and so on. You're going to square all these numbers. Well, I'm this far into it, I might as well keep going. You don't technically have to show all of this. But again, if you have a professor that wants you to do this, this is how to do it. Okay, so now I'm going to go grab Desmos, and I'm going to make Desmos find all these numbers for us. Now the thing about Desmos is it uses the order of operations, so you have to use those parentheses just like I just did. So parentheses, negative 14, that number is squared. Now the way to do squaring, there's a button above, or it's above your 6. So if you look at your 6 key, there's a little caret above it. It looks like, well, it looks like that here. I can't make it show it here. I don't know if I can even type it. Here, let me type it real quick. Oh, I guess I could write it on my paper. One sec. So the way to do it too, up to the power, in other words, you're doing x minus x bar caret 2. It looks like that. It's called a caret symbol right there. Right? It's an accent circumflex if you're in French, right? So it's above your 6 key, right? So there's an extra mark in there that isn't needed, but there you have it. So that button can do it. So it's Shift 6. Or you can also use the palette down here. There's a little keyboard down here. And if you type, let me just do the next one, 26, and honestly, the next one, it doesn't matter because it's positive. So see the little a squared? If you click that a squared, it makes it squared. And then you want to type parentheses negative 13, close parentheses, hit the squared button. Because of order of operations, what you don't want to do is negative 13 squared. That's wrong, right? Because that's making it negative. What it's doing is parentheses or exponents first, then the negative multiplying. So that's wrong. So you want to make sure you put your parentheses around your negative ones. So, right, negative 9 squared, and then we have 11 squared. And again, you can hit that a squared button. That'll work. 16 squared. And then we probably know the rest of them from our times tables from school, but 12 squared, and so on. All right, so let's go back and let's put all these values in. So this is 196, this is 676, this is 169, this is 81, 121, 256, 144, and I didn't bother, but 10 squared is 100, 4, and 9. All right, so now we're going to add these values up. All right, Desmos, I can make all this go away. You actually can just type inside what you already know. You don't have to do fresh ones every time. I just like to because I just like to. So 196 plus 676 plus 169 plus 81 plus 121 plus 256 plus 144 plus 100 plus 4 plus 9 makes 1756. So that's the total that I was making the little highlight box for down here. This is 1756 in total.